If you still remember a bit of math from your middle school years, chances are you know about BODMAS, the mnemonic for how to do math operations. Generally, you start from left to right, but as the first alphabet B in the mnemonic suggests, expression in brackets need to be sorted out and calculated first. After that, the O stands for order, which means we evaluate expression involving powers and exponents before proceeding with multiplication and division, and finally, addition and subtraction. So far so good. But have you ever wondered why we do things this way? Why not, for example, we evaluate addition and subtraction first before we do multiplication and division? How would that change things? Surely there must be a good reason for us to do things in a certain order, and the choice is not random. In this video, I'm going to address all these questions. There's a very cool mathematical fact that you might or might not know: the distributivity of multiplication over addition. What this means is that if you are multiplying a number with a few numbers enclosed in a bracket, or to put simply, to multiply 5 with 7 plus 3 in brackets, we can open the brackets and multiply 5 with 7 before adding it to the product of 5 and 3. Another thing to note is that while multiplication distributes over addition, we do not have it the other way around. That is, addition does not distribute over multiplication, and the example I show here is clearly not valid. Let's now think about the role of brackets, or the letter B in BODMAS. Why do we need brackets in the first place? We need them to signify a departure from our usual rules, which are supposed to be followed. As an example, if I haven't put in brackets around 3 plus 7, you have done multiplication first, instead of adding the numbers together, as dictated by BODMAS. The brackets here tells us that we are to make an exception to the rules. Now, suppose that the system of BODMAS hasn't been invented. Would you prefer a system where a lot of brackets would need to be used, or do you prefer a system where equations and expressions could be expressed using as little brackets as possible? To put it another way, if you are to come out with a set of rules, would you prefer there to be many exceptions to the rules you created, or do you prefer your set of rules to hold in most scenarios? The choice is evident. For the sake of consistency, you will prefer the system which tolerates less exceptions, and this is the same for our case above. As we will see below, BODMAS is a superior system as it doesn't require us to do that much bracketing, or if any at all. To see why, under BODMAS, suppose we are looking at 3 times bracket 5 plus 7. Is there another way to write this expression such that no brackets would be required at all? Remember the distributivity property we mentioned above? We could expand the brackets, and doing that will leave us with no brackets at all. On the contrary, suppose that on an alien planet, instead of BODMAS, the system BOASMD is used, where addition and subtraction are done first before multiplication and division. To express an exception, if you want multiplication to be done first, we could again use brackets. But then, since addition does not distribute over multiplication, there is no way for us to write this expression such that no usage of brackets would be required. The brackets would always be there, and we have been an eyesore and mockery of BOASMD if you have a super long expression, as if the rules are meant to be broken. Now, I'm not saying that brackets are not common under the BODMAS system, but at least under the BODMAS system, we have got alternatives to remove the brackets if we so desire. As for why exponentiation comes before multiplication, you might have seen a rule which suggests that exponentiation distributes over multiplication in an analogous way to addition and multiplication above. All this reasoning would be the first reason why BODMAS is the preferred and superior system. For our second reason, things are going to get less mathematical. I'm going to try and argue that BODMAS actually reflects the rules which are deeply woven into the tapestry and fabric of mathematics and even our daily lives. Simply put, it is just a way nature prefers to operate and do things. To show this, let's think about multiplication and exponentiation from another angle. I like to think of things this way, even though it might not be historically accurate. I always like to imagine that humans started out only with the operations of addition and subtraction. To count and keep track of, say, livestock, people in ancient times keep adding 1 to a tally. The downside to this, as you probably realize, is that we would run out of paper or ink really soon if we have a very long sequence of addition. That's where multiplication comes in. It acts as a shorthand, which allows us to replicate the process of addition a certain number of times. The logic governing exponentiation is the same. It is a shorthand of some sort for multiplication. Now let's apply the rules of BOASMD and BOASMD to the expression 3 times 5 plus 2. Under BOASMD, this looks like 5 plus 5 plus 5 plus 2, as multiplication comes first. But under BOASMD, it would look like 5 plus 2 plus 5 plus 2 plus 5 plus 2. One could see that under BOASMD, if we choose to write out the expressions explicitly using only addition, the same numbers are grouped together as if they are being laid out on a clothesline, while under the other system, the numbers look scrambled. There is little surprise that the intrinsically more appealing and orderly version wins out and ends up as a preferred system in the end. You could argue that we could group the 5 and 2 together, as addition is commutative. That is, the order you add up the numbers doesn't matter. You are most certainly correct, but under the BOASMD system, there's no need for us to even rearrange the numbers. The commutability comes free as a consequence of distributivity of multiplication over addition. The BOASMD system actually reflects how we count as well in our daily lives. Our decimal numeral system is just basically a string of numbers, each multiplied with a number of power of 10 before being added together. In the same vein as above, whenever we are using numbers, it was implicitly understood that we are adopting this clothesline system where each of the digits in our number represent how many copies of a certain power of 10 there is. Such similar association could be seen in our daily lives. Multiplication is akin to grouping same units of a certain thing together before we loosely collect these separate groups together using the operation of addition. BOASMD becomes the natural system to use under such circumstances, as this is a way we group things. Similar units of items are grouped together first, before different items are put together. If you need an example, suppose you are having a Sunday meal at the pizzeria. How would you order your meal? Does it go like 2 large pepperoni pizzas and 2 bowls of mushroom soup, which is pretty well understood? Or do you say 1 large pepperoni pizza and 1 bowl of mushroom soup, doubled? Alright, I think I've given you some food for thought. I really enjoy writing the script for this video, and I hope that you find this enjoyable as well. I hope to see you in the next video, and until then, goodbye.